So hi everyone, today we are going to talk about designing YouTube. In the previous videos, we have already discussed about designing some big applications like Amazon, Netflix, Airbnb, Slack. So these are going to be the last two videos where we are going to design a very big application like YouTube, and the next video probably will be on designing Google Drive. The last two videos of the system design series are going to be mostly about Twitch and the Reddit API, which I was thinking that would help actually even in designing an API, and that would complete the series by 30 videos. So yeah, so coming back to this video, usually with every time that we start with a system design, we actually start with questions. We start with questions, right? So you know when we are designing YouTube from a high level point of view, so YouTube is a fairly straightforward service. User go on the platform, they are served videos and shorts based on the subscription and recommendation system that we are designing with this system or something else, something like that. And should we worry about auxiliary services? So like payment or authentication? No, just like always, they are going to be handled by some third party, so we don't need to worry about this payment authentication and something. And we support every browser, the system that we are building. So yep. So when it comes to straightforward things, suppose these are your clients, and this is your service of YouTube. So if you see a simple forward model, these are going to be servers, database, and like they will be contacting them. Through them they will be get access to the service. If you see a high level overview of using client service model. So let's gather some system requirements, because we are going to design the core YouTube product, right? So third party services like payment, and ad service, ad service. Then you have authentication. These are handled by third party. These are handled by a third party. Cool. So now we know that it is going to be handled by third party. We can actually move to the main core things. There are two main functionalities. The first is uploading video. Then you have watching videos. So like yeah, these are the two core functionalities of YouTube. You can watch video or you can upload video. As a just a watcher, you're going to watch a video, and for a creator you're going to upload a video, right? So let's think like this. When it comes to an average viewer, it can watch, let's say, 5 videos per day, right? And what next? It is globally available. Then what happens next is the average video size, let's assume it to be 300 MB. It's good, 300 MB, right? And there are, let's say, how many users? Let's go with 2 billion users. Cool. And let's say out of these 2 billion, oops, so yeah, let me get back with a new pen. Yeah. So out of these 2 billion users, let's assume 10% of them watches video every day. So that is 200 million. So 200 million users come every day. Cool. So now we have clear, we have two main functionalities: uploading video, watching videos, 5 videos every day, globally available, 300 MB per video, and then you have 2 billion users in total, out of which 10% watch every day. Cool. So now we know. So now we can actually come up with a plan. So there are basically 4 things that we are going to do. 4 things. 1, 2, 3, 4. Right. So let the first thing be. We are going to talk about video storage. So video storage. right? Then we are going to talk about client server, right? We are going to talk about client server, right? So we are done with that also. Then we are going to talk about the third thing, which is the content delivery, So video content delivery. So yep. Then we have to talk about the fourth one, which is user content activity, right? So these are the four things that we are going to talk about. So now we have a plan. Now we can move forward with one by one to each of them. So let's move to the storage part, that is the video storage. Inside this storage part, there are going to be a lot of things. So let's talk about the one video content, right? So let's assume 10% of daily active users upload video. So 10% of daily active users, that was 200 million. 200 million, that would be 20 million. 20 million, and average video size was 300 MB. So multiplied by this 20 million would be multiplied by, right, 300 MB. 300 MB. So that will be what 300. So 6,000 million MB. That would be 6 million GB. 6 million GB. That is, when we scale it down, 6,000 terabyte, right? 6,000 terabyte. So we even scale that down, that would be, I think, 6 petabyte. So when we scale, things, that will make things easier for us. So that's the reason we are doing this. So every day, let's say 6 petabyte. 6 petabyte is the data that is uploaded. It's very straightforward that 6,000 TB every day. So overall we have every year 6 TB is uploaded one day. So when it comes to every year, that would be multiplied by 365, right? That would be multiplied by 365. So that would be 2200 petabyte. 2200 petabyte. So every year 2200 petabyte storage is required. So hence Google can simply use a blob storage for this, because this is a video service. So we can actually very directly use a blob storage, and then can be Google Cloud Service or Amazon AWS S3, right? But obviously they would be going with GCS, because YouTube and GCS, they are both owned by Google. So yeah, so the storage is dynamic and increases every day. So on the basis of that, we took a count of 10 years for, let's say, average. So 365, that is like this was only 22 petabyte, right? My bad, but yeah, we took a 10 years, so that is the reason 2200 petabyte. It's a lot. So yep. Now with that we are clear with this, we can move to the next part, that is static content storage. Because we know that we are done with videos, we can assume that apart from video, we will want to store various pieces of static content for YouTube's video and short, including video times, description, and card list. So that, let's assume that would be 10 KB for every video, right? 10 KB for every video. So 1 billion videos are there, suppose 1 billion videos. So that would be 10 terabyte. And that's not that big, but yeah, as based on this subscription, we can even cache the videos. Let's say an average subscribe would be, let's say, 10K. Obviously, average person subscribes to 10K videos. 10K YouTube videos. So this 10K videos can be multiplied by 10 KBs. 10 KBs, that would be 100 MB. 100 MB, right? So we can actually simply cache this data. Right? So we can store the whole data in relational database for easy access. Now there comes the next part, that is the metadata, right? User metadata, right? So storing users information, what videos may watched until they have watched it. So let's say every user watches 10K videos in their lifetime, 10K videos in their lifetime, and total of 1 billion users are there. So that would be around, that storing and everything. So let's say for that 100 bytes for everything, the metadata is of 100 bytes only. So for this whole thing, that would require 1 billion multiplied by 10k videos multiplied by 100 bytes. That would be 100 terabytes. Not that big. We'll need to query this data, so storing it in a classical relation with database like Postgres will make sense, right? Something like this. Think like this. This whole data can be stored in Postgres as a it is a relational database, so that every time a user returns, you can directly fetch all the data from this Postgres relational database. So yeah, storing 100 TB won't be that big. So yeah, so now we are done with the storage part, we can move to the next thing, which is general client interaction server, client server that we talk about. Yeah, so we have clients here. Suppose this is going to look a bit different, right? We have clients here, one client, two client, three client, right? For example, now we are definitely going to have some load balancers here. This is going to be a load balancer, right? So for streaming videos, we can actually use CDN. That when there are a lot of things, we need to have servers all across the world, because the size is very big. So the content delivery network will be needed for this, right? So for streaming the video, we can actually go through these load balancers and go to CDN, content delivery network, and these are going to be the load balancers, right? And for everything else, right, you have to upload video, or you have to update some metadata, you need to return, we can simply have some API servers, right? API servers, we can simply have that, and they are going to handle the load balancing. So there are going to be two paths. Either you watch a video, for that you're going to go to the content delivery network, or you like want to do something else except videos, watching videos, you go to API servers, right? For anything else. Cool. We can move to the next part, which is video content delivery. So let's talk about that. Video content delivery, right? So a small assumption for calculating the bandwidth. Let's say we talked about 200 million users, right? 200 million users, and let's say 5 Mbps would be required. 5 Mbps, so that would be around 50 terabytes. 50 terabytes, right? So we need thousands of locations around the world, right? So let's say this is the world map. This is the world map, and here is US, here is India, here is let's say China, and there is Europe, here is Australia, here is let's say Nepal, then here is Africa. So you need thousands of locations. You need to put a network here, then you need to put it here, because handling from here will take thousands of hours for someone to load from here to here, right? So thankfully CDN can solve this problem with many thousands of points available across the globe. So like there is this service, you already know of Cloudflare, and even Google has its own service, the Google Cloud CDN. So these servers are going to help us solve this problem. So yep, I think that was pretty it. I think we have concluded with everything that was needed. So let's draw the system design diagram. The 4 things that we talked about are done. So yep, let's look at it. Just change the color and size. Yep. So let's look at the system diagram. So before looking at the system diagram, we need to actually think how we actually design everything. So system diagram, right? So let's go through one by one. The first thing that we did was have a video storage, right? So let's have a video storage here. We will have a video storage here. Storage. Inside this, we can actually do a lot of caching and everything, but let's wait, right? Let's wait. So as we said, users can actually do 2 things, right? Users can actually, let's say these are users. Okay, that would be very big. We'll just go there and make some small users. So let's say there are 2 kinds of users. One user here and one user here. So these users are for here for watching videos, they are here for doing anything else, right? So but for the sake of this, let's consider these users are from different countries. Let's say they are from US and they are from India, right? So CDNs are going to have different implementation everywhere. No, they are going to have same. So yes, just they will have different CDNs. So one CDN is here. I will change the color for making things easy. Yeah. So this is one CDN, right? And then you have another CDN here that is for India. This is for US, India, right? And US. So they have two CDNs, and then you have this everything relational database and everything. So this was the storage content. So then you have the relational database. So this is the relational database. So we will have multiple database, right? So this is the relational database that we talked about. Then we have the metadata here, right? We have the metadata here, metadata, right? So then we have the static data, but that can be cached and everything, so that won't be a big problem. Let's say you have one more database here for this, for loading the first time static, right? So yep. Now we will have some servers here that are going to help us fetch through them, right? So let's say API server, and one more API server. They are going to be multiple for each one of them, but for this sake, let's consider this. So they are going to help us relocate. These are the client server model just as usual, and this CDN is going to call to load balancer here, multiple load balancers, and then it is going to redirect to the API servers, and we are going to get the request, right? Simple as that. Nothing that tough. And we can even do some caching here. This particular place, we can do some caching here. So this caching is going to help us achieve the fast thing that we talk about 100 MB, that you storing the users watched videos, timings and everything. So we can cache here, right? And similarly this how it will happen at US, it will similarly happen here also. So like suppose this is for watching for videos, you will get it from here, right? You will get it here, but for anything else you will go here to the load balancer, right? Now similarly, if someone from US is watching, it is going to also get cached, right? And it is going to go here. So everything remains same, just the CDNs are different here, right? Everything else is same here. So this is how the whole system design architecture of that will be looking like, right? Yes. So yeah, it was a pretty small video because we have already talked about Netflix, so you guys already know how things work. So in the next video, when we are going to talk about Google Storage Drive, it will be pretty cakewalk for you guys, because you guys have now already achieved a high level overview of how to start with system design videos and how to go overview, right? So yeah, that was it from my side. Thank you and have a nice